Welcome back everyone to the Hello World Guide. This is another episode of the Raycaster series, and in this video we are going to implement some of the gameplay mechanics for our monster and some other stuff as well, and basically stretch out our foundation for having more stuff into our game. So we can go ahead and start off by making a better sound system. So first of all, there are a couple of things in sound. It used to take a vector 2, but since our game is essentially 2D, we are going to change it. It used to take a vector 3, we are going to change it to a vector 2 since our game is 2D. And in sound.cpp you can see that SFML requires of course a 3D vector, but we just pass the Z value as 0, and this is the same way we do it for the player, so this should work correctly. And another thing is that now our sound also takes a optional min distance argument, which is by default 1, and this allows us to kind of make some sounds that are louder than others, some sounds that can be heard at farther distances, because the min distance represents the minimum distance at which the sound is played at full volume, and then at distances greater than that the sound is not played at full volume. It's the volume is reduced depending on the distance. So now let's go ahead and take a look at animation. In here I just added a couple of other utilities. One is that early on when we were exiting from an animation that was not looping, then we were just going back to the default -1 animation, which means no animation, the base animation or the base frame actually. But now we are doing it a bit differently. So inside of animation we'll have another two new variables. One is a last value as well, which represents the last animation or the last frame, whatever we were using, and the last looping represents whether the last state of the looping variable was true or not. And what we do is, instead of going back to -1, we go back, set our looping to last looping and set our current to last, instead of current to -1 and looping to false or whatever. And then we set our last to be -1, so that when we go to the last one, the other last is going to be -1, so if it shouldn't play that, it will not play that. And when we are setting our animation, we set our, before changing our current, we set the last to the current one, so that we can store which animation was the last one before we transition to our new animation. And similarly we do for the last looping before we change that, and then when we are going back to our previous animation, we use these variables. And another thing is that now we want to be displaying sounds from different places, so we are going to go under resources.h, and we are going to add another unordered map of strings to sound buffers, and this is going to be our sounds. So we're going to store all of the sounds based on their name here, so that we can access them and use them. So if I open up resources.cpp, what you can see is that we've just got that defined here, nothing actually that special. And in main.cpp we actually use a directory iterator for that. So by the way, we are also going to use some random number generation, so we just seed the random number generator. We could use C++ random number generation, but we are going to just use the C one because it's a bit simpler and we don't really need that much complex random number generation. Anyways, we go ahead and loop over each of the entry in our sounds directory, which I have just which consists of just the appropriate sounds. Currently it consists of a few sounds extracted from the original Doom source code, so it's basically monster action.wav, monster pain.wav, along with weapon sound of course. And now you can see we basically check if it's regular file and if its extension is the WAV format, and then we go ahead and get the name of it and we load it from the file. As you can see, we are doing it here. That's all pretty cool. So now I'm gonna go ahead and open up player.cpp. You can see that now where we were taking, using that resources player sound. Resources earlier had only a weapon sound variable. We don't have that anymore, but we just use the sounds and access the weapon sound from the unordered map, which is all pretty cool. Now the other thing is that if I go ahead and open up thing.h, we have got a lot of new features for this. So you can see we have got a float time here, which is used by monster to time different things, or basically any other AI. So we initialize that to 0, and it's actually changed by the thinkers themselves. The think class doesn't actually change it. And inside of our thing.cpp we have kind of changed the organization a bit. So now we have got two functions. One is monster update, which is a bit complex, we'll go over this in a second, and monster on damage. And when creating the thinkers, we just create it for the monster with our monster update and monster on damage, just like that, without having the lambda be inline, so that we can have our more complex functions here without having to it would kind of be a mess if we were to implement that here. And you can see I've got a new animation for monster, which is the run animation. I just extracted the images from the original Doom, which you can get on the GitHub. You can get the same images on the GitHub repo of the project, or you can extract the Doom images from an editor like Slate. So anyways, we've got these here, which are basically, of course, we only specify the first part of the directional sprite here for the animation, and the others are computed automatically. and you must make sure that the directions are in alphabetical order. At any rate, for our monster on damage, what we do is if the thing that get health is less than or equal to 0, we of course destroy that thing. Otherwise, if our thing has an animator and the animator state is idle, then we set it to state run. Now these are basically some enums that we have defined here. State idle is -1, the default one. State run is 1, the second animation, and state pain is 0, the first animation. And this is basically like a state machine, but we reuse basically our animation code for the state machine. And we have got this get anim function in the animator which returns the current animation, and if it is idle, that means that the monster is in an idle mode. We want to make it chase the player, so we set it to run, and the looping is of course set to true for the running animation. And after doing that, we actually immediately transition to pain. What that does is that after pain, the last value of our animator would become run. So when we switch to pain, it would display the pain animation which is not looping, and after it ends, it will basically do the run animation again. And then we use sound play to just play the monster pain sound at the thing's position with a minimum distance of 5, so the pain sound is a bit higher. Now when we are updating our monster, we get the current animation and we get the player which is present in the game now. So in game.h we have got a new function which returns a reference to the player, and we get that, and we get the thing of the player which is the public of course member variable, and then we go ahead and get our player direction. Now the way we get the player direction is of course by taking our player position and subtracting from it the thing's position, which gives us the direction from the thing to the player. And what we do is we subtract from the thing time the delta time, which of course we use this for timing different events. And the thing is, we actually use this for timing the display of monster action sounds. What that means is that after a random delay in Doom, the monster usually usually kind of has a weird kind of sound, and that the monster says whether it's running or idle state. So we are going to basically check if the thing's time is less than or equal to 0. If it is, then that means that we should probably do it. So we set the time first of all to a random value. We get the random converted to a float divided by randmax, which gives us the value between 0 and 1. Then we multiply it by 8 and add 4. This gives us a value between 4 and 12. So randomly, after a delay of 4 to 12 seconds, we will display this sound. Then we play the sound, and we basically give it the monster act sound. The minimum distance is now lower too, because this isn't supposed to be that high of a sound. And after doing this, we get our animation. If we check if the state is idle. If it is, then we get the direction of the thing, which we just use cosine and sine for that. And then we calculate the dot product. The dot product, as you know, is negative for anti-parallel vectors or vectors pointing in different directions. So we check if the dot product is positive, and if it is positive, that means that the the monster can see the player. So we set the animation to the running state. And if the state is running, which means the enemy is supposed to be chasing the player, we currently do not implement any chasing logic, but what we do is we set the angle so that it faces the player at all times, and we just use 8 and 2 to get the correct angle according to trigonometry, and then we just convert it to degrees, because that's what our angle uses. It uses degrees, not radians. So that's pretty much really all we need to do, and that should cause it to work pretty much correctly. So let's go ahead and try to run make and see. I'll take a look at how it works basically. So you should be able to see that the monster does play a sound, which is the default chase sound, and the monster should play it again after a random interval. So as you can see, the monster plays the sound again, and it's quite faint. It's not that problematic, but you can see if I go in front, the monster goes into chase mode, and now the animation is set to chasing, and it stays there regardless of where I go, and the monster is always facing me. And another thing I can do is I can shoot the monster from behind, and he automatically faces me. So you can see the monster has now turned its face to me, so that means that the state has changed, and it will stay like that. And of course I can shoot the monster, and it will get removed from the map. So you can see that is some basic gameplay mechanics that are working. So this is going to be pretty much it for this video. In the next video we are going to be taking a look at some path finding to make the monster actually follow us. So yeah, we'll do that in the next video. Make sure to like and subscribe and share this video with other people as well, and I'll see you in the next one, and bye.